Okay, in this video, I'm going to compute the derivative of 1 over x to the n. So I'm sort of trying to build the power rule right now. So I'm assuming that n is a positive integer, and I'm assuming that we know that the derivative of x to the n is n times x to the n minus 1. So we can use Pascal's triangle from the last video and the definition of the derivative to prove this. And now I want to use this to show that I can do this with negative powers as well. So this is trying to take the derivative of x to the negative n, right? And so if I try to do 1 over x to the 10th, it's not a polynomial anymore. So say n is 10. It's not a polynomial anymore. It's a rational function now. And so I can't use Pascal's triangle. If I try to write down the definition, it's not a polynomial. So the Pascal's triangle method is not going to work. But I can try to use this, what we already know, to calculate this and use the definition. Okay. So the first thing to notice is that x is not 0, okay? So throughout this, I can assume that x is not 0 because when x is 0, that point, like 0 is not in the domain of this function, right? That would be a division by 0. So the function is undefined at 0, so it definitely doesn't have a derivative at 0. Okay, so throughout, I'm going to assume that x is not 0. So let's do this using the definition. So it's the limit as h goes to 0 of f of x plus h. So that's 1 over x plus h to the n minus 1 over x to the n, so minus f of x, divided by h. Okay, and so we need to try to take this limit, right? So unfortunately, like these two things are confusing. Both of them are undefined. Sorry, they're not undefined. When h goes to 0, that's the numerator goes to 0, right? The numerator goes to 0. So, and the denominator goes to 0. So we need to simplify somehow. So if I have fractions, a way that I can simplify this is to find a common denominator, right? So this becomes the limit as h goes to 0. And now the common denominator is the product of these two things. So the whole thing's still going to be over h, and then my common denominator is going to be x plus h to the n times x to the n. And what do I get when I put this term over this common denominator? I get x to the n. And when I put this term over the common denominator, I get x plus h to the n. And I'm gonna factor out this common denominator and write it on the outside. So this is limit, not on the outside of the limit, but I'm just gonna write it as a separate term. So this is limit of 1 over the common denominator. And now this is times what's left over. It's this term, x to the n minus x plus h to the n over h. And now as h goes to 0, this term is going to 1 over x to the 2n. And x is not 0, so that's well defined. So this term is approaching a limit. And now let's look at this term. So to make this easier to understand, you'll see why in a moment. I'm going to multiply this by, -1 twice, okay? So I'm multiplying by 1. So this is the limit as h goes to 0. So one of the negative ones is going to go here. And the other negative one is I'm going to multiply this by -1. So this is times x plus h to the n minus x to the n over h. So I multiplied by -1 twice, right? This became negated and this became negated. So then the limit is the same. I'm multiplying by 1. And now this is the difference quotient if the function was x to the n, right? So this limit as h goes to 0 of this term, this is the derivative of x to the n. It's the definition of the derivative of x to the n. So this becomes, the first term goes to -1 over x to the 2n, right? So that term as h goes to 0, this is x to the n, this is x to the n, so this is x to the 2n. And x is not 0 again, so this is well defined. And now this is the difference quotient. So this is times the derivative of x to the n. And we know this derivative. It's n times x to the n minus 1. So this is -1 over x to the 2n times n times x to the n minus 1. And now I can cancel some of the powers. So this becomes -n over x. So there's 2n on the bottom, and I'm canceling n minus 1 of them. So it's x to the n plus 1. And this is the derivative, and it satisfies this power rule. It's the same. You take the exponent, you bring it down. So the exponent was -n, and then you subtract 1 from the exponent. So the exponent was -n, and now it's n plus 1.